Welcome to edenbrain.com. Today we'll see equivalence between epsilon-NFA and NFA. So the topic is equivalence between epsilon-NFA and NFA. Now what is epsilon-NFA? Epsilon-NFA is called as NFA with epsilon mu. NFA with epsilon mu. Okay, so this is another name of epsilon NFA. Now what is epsilon NFA? First of all, we will see the example of epsilon NFA. I will draw one NFA for you. It means if on transition line epsilon comes, then it is called as epsilon NFA. Actually, regular NFAs are drawn for the input alphabets. Like input alphabets can be AB, right? Or input alphabets can be 0, 1. Like that we have input alphabets, but we can't have input alphabet as epsilon in a general NFA and DFA. But there is a special case of NFA where we can have a epsilon on transition line, and that is called as epsilon NFA. Why it is NFA? Because the transition of 1 is missing here and transition of 0 is missing, and that's why it is called as epsilon NFA. Now we'll see a equivalence, means we will see a question. This equivalence means convert epsilon NFA to NFA. So this is actually the theme of this topic. We will convert a given epsilon NFA to NFA, right? Now how to convert this we'll see with the example, and the question is construct epsilon free NFA, construct epsilon free NFA equivalent to epsilon NFA given below. Epsilon NFA given below. So this is the question. Now let's see which NFA is given. So this is a start state called as Q0. There is a transition of 0. Then there is epsilon mu here. And then we have a Q1. Then we have a transition of 1. And on Q1 state we have a mu of epsilon, right? We have a mu of epsilon which goes to the final state called as Q2. On Q2 again we have a transition of 2. So this is what is given as a question. Now this is a question. Let's try to convert to the NFA. So let's find the answer for this. Now main part is there are some steps are required. So there are some steps required. So some steps are required. First step is calculate epsilon closure. Calculate epsilon closure of each state. Calculate epsilon closure of each state. Second, transition function. Find transition function. Find new transition function. I can say find new transition function delta dash, you can say, or a delta dash. Okay. Now third step is number of, now not that will not be called as a state, third state, but it's a note kind of stuff. Note is number of states will not change. Number of states will not change. And the fourth part of this is make those states final. Make those states final from which from which states we can reach final state by reading only epsilon, so be with me, don't worry about these steps, we will explain these steps in detail, right? So this is what the steps are required. Now what I will do is I will go and I will start doing the first step itself, right? So what is the first step? The first step is calculate the epsilon closure of each state. Now what is epsilon closure? I will say, so let's define epsilon closure. Epsilon closure of Q0 is equals to Q0 union with, now again it's a set, all those states which are reachable from Q0 by reading only epsilon, Now we'll see what epsilon closure is actually. Let's take the epsilon closure of Q0 itself. What is epsilon closure of Q0? I will explain here itself. So let's try to find the epsilon closure of actual Q0. So let's see what is epsilon closure of Q0. It will be definitely Q0 union with some states. What are those states? Now from Q0, can I go to Q1 by reading only epsilons? Yes, it is quite possible. You can see that from Q0 to Q1 I can go reading only epsilon, and that's why Q1 will be part of this set. Next, let's see, can I go to Q2 by reading epsilons? Yes, from Q0, if I read two epsilons, this epsilon and that epsilon, then I will definitely reach to Q2, and hence I got the epsilon closure of Q0. What is epsilon closure of Q0? I can call it as Q0, Q1 and Q2. I hope you understood this, right? So that way you can find the epsilon closure of all these states. How many states are there? 3 states are there. So let's find the epsilon closure of the next states. So epsilon closure of, I can say Q1. Epsilon closure of Q1 is equals to Q1 union from Q1 by reading only epsilon. Where I can go? I can lead to only Q2, you can say that, and that's why the epsilon closure of Q1 is Q1, Q2. Similarly, you can find the epsilon closure of Q2. What will be epsilon closure of Q2? Q2 union with the number of states which are reachable by from Q2 reading epsilon. I think there are nothing reachable from Q2 reading epsilon, so finally what I get a Q2 only, right? So these are the 3 epsilon closures. This is 1, this is 2nd, and this is 3rd. So step 1 is done, right? Now let's move to the step 2, right? What is the next step 2? Step 2 is find the new transition function. How to find the new transition function? So the new transition function delta dash will be defined as, I will define for one input on Q0, let's say for 0 I define. How to define? It is defined as epsilon closure of, and there is again a function which is actually a original transition function, and on that transition function you have to do again a epsilon closure. So what I will do? I will do epsilon closure, comma, you have to make epsilon closure of someone, so I will make, let's write this here. What I will do is I will write this part here. So for your better understand, I will write this part here. So that will be delta of epsilon closure of Q0 itself with 0. I hope you understood this. What it is actually speaking, I will write it again for you. It is equals to epsilon closure of delta of epsilon closure of Q0 with 0. So this is the required thing I can say. Okay, so this is what. Now let's try to find the answer. What will be the answer? So we know the epsilon closure of Q0. What is epsilon closure of Q0? You can see that Q0, Q1, Q2. So write it again, epsilon closure of with a delta. Now you will be having three stuffs here, Q0, Q1, Q2 with 0. I can say with 0. Right? So now let's find a delta of Q0 with 0. It means find delta of Q0 with 0. Right? Now what you will get? Delta of Q0 with 0. Let's find Q0 with 0 is Q0 itself. Right? So, and then delta of Q1 with 0. There is no Q1 of 0. So I think that is again phi, and then delta of Q2 on 0, that is also phi. Means finally you will get delta of Q0 only. So what you will get finally, epsilon closure of, so delta of that thing means it will be Q0, right, phi and phi. It means actually speaking it is equals to epsilon closure of Q0. What is epsilon closure of Q0 again? That is Q0, Q1, Q2. So that way you should be able to find the new transition functions of each state on each alphabet. So now let's, if you understood this, I will do it again for you. I hope this is well known to you now. So now this is the part where I will be explaining the transition function, and the transition function will be for Q0 on 1. How to have the transition function of Q0 on 1? It will be equals to, let's write it again, it is epsilon closure of delta of epsilon closure of Q0 on 1, right? So this is what we are worried about now. Now what is epsilon closure of Q0? We know that. So again write that epsilon closure of delta, and what is the Q0's closure? It is Q0, it's a set, I can say Q0, Q1, Q2, and then 1 will be there, right? Now it means go and find the transitions of Q0 in the given NFA, epsilon NFA. So I will come here, it's a given epsilon NFA. On Q0 for 1 I don't have anything, so what I will get? Epsilon closure of, I will get a set again which says first is phi, second of Q1 on 1, of Q1 on 1 is Q1 itself, of Q2 on 1, on Q2 1 is again phi. So finally what I can say, I get a epsilon closure of Q1. What is epsilon closure of Q1? Epsilon closure of Q1 is written here. You can see that epsilon closure of Q1 is a set Q1, Q2. And that way you should be able to find all the new transition functions, and I will directly write the transition function. If you understood this, you should be able to draw for Q02, which will be equals to Q2, and similarly I will have the transition functions of Q1, 0, which is equals to phi, transition function, new transition function of Q11, which is equals to Q1, Q2, transition function, new transition function of Q12, which is equals to Q2, and then the new transition function Q20, which is equals to phi, new transition function of Q21, which is equals to phi, and the new transition function of Q22, which is equals to Q2. I hope you understood, and that way you should be able to get the new transition functions, right? Now what our job is? Our job is to make it more simplified now. So let's first find the new NFA, right? The new NFA will be definitely epsilon free NFA. These all transitions will give you an epsilon free NFA, and I will draw the epsilon free NFA in front of you now. So everything is in front of you, all the transition functions are written here, right? And now those transition functions will be used to draw epsilon free NFA or NFA without an epsilon moves. How to do it? So the states will not change, Q0 will be there. On Q0, if I get 0, where I go to? I go to Q0, Q1, Q2, right? So I required Q1, Q2 also. I required Q1 and Q2. I required Q1 and Q2. Both are final states. Why to make these states final? Now let's come here. There are some steps. Number of states will not change, and make those states final. From which states we can reach to the final state by reading only epsilon. So let's go back here. You can see that by reading Q0 with epsilon, on Q0 for epsilon I can go to the final state, and that's why Q0 will be final state here. On Q1 also, by reading epsilon I can go to the final state, and that's why Q1 is also final state, and already Q2 is a final state. So I hope that is the fourth step, right? Okay, now what we will do is, we required these transitions. So on Q0 for 0, I'm going to Q0, I'm going to Q1, and I'm going to Q2 also, right? Similarly, let's take on Q0 for 1, where I'm going to Q1 and Q2. I'm going to Q1 and Q2. Now let's go to the next state. On Q0 for 2, where I'm going to Q2. So that way you can see this. On Q1 for 0, I'm going nowhere. On Q1 for 1, I'm going to Q1 Q2. I'm going to Q1 Q2, and on Q1 for 2, I'm going to Q2. So I'm going to Q2. Okay, and now the final thing, on Q2 for 0 I'm going nowhere, on Q2 on 1 I'm going nowhere, on Q2 for 2 I'm going to Q2. So yes, and this is a final epsilon free NFA. I hope you understood this. Now what is the problem here? Actually this is very lengthy process. You can see this is very lengthy process. What I will do is, I will try to convert this to the shortcut, and in the next video you will be able to see how to draw epsilon free NFA with very less time and with a very shortcut time, right? So thank you very much for watching this. If you really liked it, do like it. Please subscribe to our channel for further videos, and if you have any doubts, please put it into the comment. I will really get back to you. Thank you very much.